we will speak a little bit about metal packaging and cans, metal cans. So we will follow a similar agenda. Explain a little bit about the composition and the type of materials. We have the coatings, and then we have different types of cans, and a little bit on food and can interactions, and specifications and testing. Okay, these are the basic 4 materials that are used to produce food cans. We have 3 different types of metals. The most common is what we call the tin plate. That's basically steel coated with tin. So we have a steel sheet that then it has a coating in both sides with tin, and we call tin plate. We have aluminum. That's the second mostly used metal. And we have, for some applications, the steel coated with chromium instead of tin. And this is called the ECCS, so that stands for electrolytic chromium oxide coated steel. And the 4th material that we need is an organic coating to avoid the direct contact between the food product and the metal, because in many occasions that gives rise to high migration of metal, and this is not acceptable from different points of view. So we, in most situations, we use organic coating either inside and outside of the can. This is a representation of the structure of the materials. We have the tin plate, the tin-free steel, that stands for the chromium coated, and the aluminum. And so this is represents the steel. Then we have the tin. In the between, it is formed an alloy, so a mixture of the steel with the tin. I think you know what steel is. You know what steel is? Yeah? What it is?
Iron and carbon.
Okay, good. Iron and carbon. That's why we have this alloy formed with tin and iron. And sometimes, not always, but sometimes we have a passivation layer after the tin, and then we have the lacquer. The lacquer or the coating. I use these 2 words interchangeably. For the tin-free steel, so we have the steel, and instead of the tin and the tin alloy, we have chromium and chromium oxide. Chromium oxide is a passivation layer, and then we have the lacquer. So this is in one side. For the other side, we will have the same, okay? So I just represented one side, on one face, but it would be the same on the other face of the steel. It will be also coated. For the aluminum, we have aluminum alloy. Is never used pure, but is an alloy with different components. Then we have formed an aluminum oxide layer, and then we have the lacquer. So these are the structure of the metallic components. So the tin plate, that's the mostly used. So it's a low carbon mild steel, and the tin is applied to protect from corrosion. So we apply the tin to protect the steel from corrosion. And the tin coating weights, that means the amount of tin that we apply ranges between 2.8 and 11.2 grams per square meter. And this is also standardized, okay? We don't decide, oh, I want 5.0. No. We have a number of combinations and a number of coatings that the metal sheet that we buy comes with. We just select among those that are available in these industries. However, we can apply, or we can have sheets with different amounts of tin coat in each surface. I can have what we call differential coatings. That's coatings where outside and inside of the can the amount of tin is different. Okay, I select the tin coating weight according to the corrosion protection I need. If I need a high level of protection, I select a high weight tin coating, like more 11 or something like that. But if I don't need a high level of protection, I can use low levels of tin. And these requirements on corrosion protection, it depends on the product. If I have a product that is cookies, like the metal can that we had next to the coffee machine, is dry product, is cookie, I don't need a high level of corrosion protection. But if I have a tomato sauce, I need a high level of protection because it's liquid, acid, so I need a high level. So in this picture, you see some metal with some lines, some strips. Okay, these strips are the marking lines indicating that we are using differential coating of tin. That means that inside and outside I have different tin coatings. And the distance between each line there is a standard here, and it indicates the code type. For example, if I have 12.5 millimeters strips distance, it means that I have a differential code with 5.6 in one face and 2.8 grams per square meter in another surface of the can. Clear? No. Maybe. Yeah? Do you want me to explain in a different way? Yes or no? So, I have tin coating in each side. Here I have the same, like 2.8 and 2.8, or 5.6 and 5.6, 8.4 and 8.4, and so on. So this is the same coating, the same amount of tin in each internal and external side of the can. Okay, it's the same, so I don't do anything. But if I want to do inside and outside a different amount of tin, I need to indicate that I can have, for example, 5.6 in one face and 2.8 in the other one, or 11.2 in one and 2.8 in the other. And so I need to use these marks to indicate where is the different coating. So from now on, when you open a can, you can see inside if you see some stripes like this. If you see them, it's because you have a tin can coated with a differential amount of tin inside as compared to outside. If you don't see any of these strips, it means that you have the same inside and outside. Of course, this is not important for the consumer. I'm just using this to explain, because as a food industrial, you need to select this in advance. Okay, for the chromium coatings, is more easy. Typically we use 80 milligrams per square meter of chromium and 20 milligrams of chromium oxide. That's the regular. And we will see this a little bit later, so I don't need to explain now. For the aluminum, so we have an alloy, as I explained. We have aluminum, different alloys according to the use. If it is for a tube, or for a can, or for a foil, a wrapping aluminum foil that we use in the kitchen, for example, or a small tray. So aluminum is used in packaging as different alloys with different composition, okay? For these cans, it's typically high purity, 98 to 95. And the other components that are important are like magnesium, silicium, iron, manganese, copper, and zinc. So to provide for different properties that are important for the can. Cannot be used for high acidic foods, especially uncoated, and typically is always coated to avoid this contact direct with the beverages or with the food. Let's say the comparison between these three different metals, and I will jump a little bit ahead just to show you the cans types, because I start to use some terminology, and then we have the 3 pieces cans, which are like these. Are 3 pieces because we have a top, a bottom, and a body. Here is not easily seen, but there is a seam somewhere on the body. So the body is seamed. So we have 3 pieces, 1 piece, 2 pieces, 3 pieces. And these are 2 pieces, in this case 2 pieces food cans and 2 pieces beverage cans. The difference is, okay, 2 pieces. We understand that in this type of cans, the bottom and the body is only 1 piece. So we don't have a seam on the body. So it's 2 pieces because we have body and bottom, and we have the lid. And this is the same. It's a tuna can. So we have the side and the base in one piece, and then we have a second piece as the lid. Okay, so 3 pieces cans, 2 pieces for food, 2 pieces for beverages. The type of processes are different, but I will speak about this later. Let's go again to the comparison. So there is here the welding capability as a criteria, and we see here that aluminum cannot be welded easily. So aluminum is not ever used for 3 pieces can, because we cannot weld to produce the body. So aluminum is only used for 2-piece can. For ends, for lids, for tubes, for trays, aluminum can be used. So it's good resistant to sulfide staining. Sulfide staining is a reaction that occurs in metal packed products when the food product has sulfur in the combination, and we have tin or iron in the can, and there is a reaction, and the sulfur combines with the tin or with the iron, and there is some spots that appear inside the can. So this is not called corrosion, is an interaction, is another interaction type of reaction. And aluminum is good resistance to this sulfide staining because it does not have tin, it does not have iron, so the reaction cannot occur. Like here, like in this tin-free steel, also this sulfide staining, the reaction with the tin cannot occur, just with the iron. But apart from that, aluminum is very good in terms of shaping capability. So we can produce nice shapes, differentiation, cans with a different shape, which is possible and more difficult with the tin plate. So we have these benefits and advantages and disadvantages. So we have good corrosion resistance in here. We can use the tin plate for 3 pieces can. For the others materials, we only can use to produce 2 pieces. Then on the organic coatings or lacquers, that's the 4th component. Okay, it's a polymer type that is applied on the internal and external surface. So plastic is really important because even in metal, even in glass, we have somehow some polymeric applications. So it provides some chemical barrier between the metal surface and the food. And there is a limited number of applications where we don't coat the metal, like the cookies can that we saw in the coffee machine, and some specific situations. So in the rest, we need to avoid the contact. And so coating must withstand with the production steps. Sorry. All the production steps of the can, so the coating must withstand with those. And as you know, in most of the cases, metal cans are used for thermal processed foods. So we packed the food, we close the can, and we thermoprocess the food in the can. So the metal, the can, the coating must stand for this heat treatment as well. And so the internal coating protects from the metal contact, avoids iron pickup in beer, which gives a very strong flavor in beer. There are some dark colored fruits like plums and strawberries that, if not coated, they become discolored in the can. And also protects the can from the food itself, because some food, like the acidic soft drinks like Coca-Cola, which is highly acid, or some food rich in proteins like the cases that I mentioned that can cause sulfur staining. So the coating is required to protect the can from the food, okay, from these type of interactions. Then we have the external coating, which is also important to avoid corrosion from the environmental so the atmospheric humidity during storage, it's important. In most cases, is supporting for the decoration and printing, labeling is applied directly in the can, so we don't need a paper label. And it's also important to reduce friction. They act as a lubricant to make the cans during filling operations to pass through quickly in the machines. So it's also important there. Okay, and here are some examples of the coatings. We have a major class is epoxy phenolic, epoxy plus phenolic. So it's like a polymer. So we have some epoxy and some phenolic, and therefore we can have a range of lacquers depending on the proportion of epoxy and phenolic. And we can also, so they have good flexibility, and we have good chemical resistance for when we pigment the coating. We have good heat resistance. And so this is the most widely used coating for metal cans, for food cans. If we open a fish can, most likely, how is the color typically of the cans that you consume, if you consume any? Not the beer ones. The beers is different. Starting with the point that we are not able to look inside because the opening is different. But food cans, can you say the color of the cans inside? Typically, or is golden or white. If it is golden, it will be epoxy phenolic. Okay? If it is white, it may be epoxy amine or epoxy acrylate. Is universal for beer and for beverage cans. So we have also polyester. So you can, some vinylic also. So there are a range of options and selection depends on the can type, first of all, and the product, of course, and together with that, the process that the product is going to be submitted to. So we covered this already, and here is how the 3 pieces cans are produced. So we have a body, a top, and a bottom end. So we cut the metal in sheets. We coat the sheets. We cure the coatings. Then we cut again in small body parts. Then we bend it and we weld the body. Then this is spraying and curing. When you look into inside of sausages cans, you can see a white strip typically there. We are speaking about 3 pieces cans, so sausages, and if you look inside, you can see a stripe of a white coated lacquer. So this is where it is applied here, and then with the cylinder produced, we start to do the can in preparation to receive the top and the bottom end. Okay, and then we can do some. So we do some double seaming. We will see what this is, and then we may need to produce some fixtures on the body that we will discuss a little later. So here are some terminology. This is the double seam. This is the canners, and so one end is applied to the body in the production site. The other hand is left open in order the can to be filled, and it is closed by the filler. Okay? It can be the top or the bottom, depends. Okay? It is not necessarily the top. In most cases, in fact, it is not. The cans are filled by the bottom and closed. Okay, in this case, I know that this is the canner's end because it has the lot of the food products stamped here. So it's printed here. You see these letters? So these must be marked when the can is filled. So this must be the end that is applied by the canner. By the food canner, that's what I mean, okay? You see here the welded side seam is very clear. So if you have a labeled, a paper label, this may be hidden. But if you take out the paper label, you see this welded side seam. Inside we have a gasket, and here are the beads. Okay, this is like a corrugated body, and I wonder if you know why do we have this corrugated shape type of body in the can. Second guess? Hi, Maria. Is to increase the resistance of the can while being able to reduce the metal thickness. Again, reduce, reduce, reduce. So here is the explanation. The mechanical resistance of the can depends on the sheet thickness, on the sheet hardness, so intrinsic characteristics, and on the can body geometry. And here you have 3 examples of 3 cans with different characteristics and theoretically with the same mechanical resistance. Here I have no beading. I have a thickness of 0.26 and the hardness is standard. Okay, I can reduce the thickness from 26 to 21, still keeping the hardness of the steel, but I need to use beading. Or I can reduce further from 26 or 21 to 17, keep the beading, and I have a different metal hardness, so a more hard metal. So if I weight these 3 cans, I have a much lighter can, but still I have the same mechanical resistance. So I play with characteristics of the steel, I play with the thickness, and I play with the geometry of the body. And this is how industries can do lighter metals, metal cans, without compromising the performance. Okay? When we go to cans production of 2 pieces, okay, we have basically the food type cans. So we start with a sheet, and then we start to draw on the can, but we don't change the thickness of the metal. This is how redraw can is produced. While when we want to do a beverage can, okay, we start with a certain thickness, but we increase the size of the can by ironing the metal. So the can starts to be thinner and thinner and thinner. So beverages cans are typically very thin, while the food cans are not so thin, are thicker. So the process is different, and because of this, we because it's used different types of processes. Okay, this is more or less how to put some socks in our body. Okay, if we are putting some socks like for jogging, short socks, right? We put the sock and we don't stretch almost anything. So the thickness of the sock behind our foot and on the ankle is more or less the same thickness, right? Okay? It's a short sock. If we are a lady and we are putting some pants up to here, so we need to stretch a lot. What happens? The thickness of the pants underneath the feet is much higher than the thickness on the leg, right, ladies? Yeah. So this is the difference. When we are doing using a sock, is like a short sock is like a drawn food can, or when we use a paint is like a draw beverage can. So we have much thinner walls than in the other case. Then we have other types of packagings like aerosols, we have tubes, and we have higher capacity like buckets and bins that are used in industry, so as intermediate packaging. On the cans ends, okay, we notice that the cans are not, the ends are not flat, like we have several expansion panels, like here, and these expansion are to allow the expansion of the can when the can is being processed. So when we are thermal treatment the food inside the can, we have an increase in volume, an increase in pressure, an increase in volume, so the can expands. And we need to give some, to allow for some expansion rings to avoid this irreversible deformation that could compromise the can integrity. This is why the ends do have these expansion panels. We have then the easy open ends is very important for consumer convenience. And we have the full panel opening for food. So when we have this type of ends, we can remove the panel and we will have access, or we can have a stay on tab opening and for drinks, so that allow us to drink from the can without spilling all over. And this means that there is only a small opening in the panel, is not a full opening. And here we have some details on how this ring is attached to the end. Very importantly is how we close the can, and we use a double seam. So a double seam is, in fact, is produced in 2 steps again. So we have the flange of the can body that comes in contact with the can hand. We have here the gasket, or and then everything is rolled together and then compressed into the final shapes. So we have 1 step, and then on the 2nd step this is compressed to the last picture. And this is how it should look. And all these types, different portions of the double seam has names and specifications. So in a can industry, all these details are measured and controlled as a normal routine of quality control. So if you work in any food plant that uses metal cans, you have people going to the lines, collecting cans and checking for these all set of parameters that compose the double seam. For example, if you want to export some food into United States that is packed in a metal can, like a fish product, for example, you need to have in your plant people that are trained and certificated as to know how to do this according to specific courses that FDA issues. So you need to have people training and certified to do this. Otherwise, your cans don't enter in United States. Okay. And finally, here we have some interactions. I think Professor Lawowski yesterday showed some corrosion images. Here we have also a little bit. So this is in the internal side of the can next to the welding seam. And this is typically one point of the can where the corrosion, if there is corrosion, it starts. And here we have a representation on how corrosion occurs, because we have the iron from the steel, we have the tin from the coating. So we have two metals with different electrochemical potentials. We have a food that is rich in ions, so we have a good transmission of, so we will have iron acting as cathode and tin acting as anode, and we will have some release of tin into the food. Okay, as long as this is under controlled conditions, that's okay. If there is uncontrolled conditions, that occurs in a very, very uncontrolled way, so we'll have too much tin, and or if we have this process running on the other side that we don't want, we'll have the tin being corroded, and this is very aggressive corrosion, and we have leakage on the can, and we have a loss of the product. Okay. So there is a number of factors that affect corrosion. So corrosion depends on the metallic composition of the can, but a lot on the composition of the products. And so agents in the food that can complex tin, like oxalic acid, like tannins that are natural in the composition of some products, CO2, nitrile groups that sometimes can be present in as part of the food, and temperature. Of course, the temperature, the higher the temperature, the faster these reactions can occur. Okay, and then of course, if we have a good organic coating, a thick and without porosity, so if we have a good protection of the coating, we will not have this effect, because we don't have the contact between the metal and the food. In the sulfide staining reaction, so as I said before, if I have in the composition of my food, if I have thioproteins, so proteins where sulfur it is on the composition, and if I have a thermal processing that is not very well controlled, I may have the formation of these species during thermal treatment, and this can then be related with the iron, and there is some black stains formed in the metal, and we may have tin, and we have these gray stains formed inside the can. Okay, these are not toxic things, but I'm sure that consumer is not prepared to see these stain spots inside the can. So they are avoided, and there are a number of approaches, namely on the coatings, to avoid the consumer to see those stains. So typically there is a lacquer or coating or an enamel with a strong reticulation capacity, or we have some kind of pigments in the lacquer that avoids the consumer to see these spots, and these are typically the solutions, the approaches that are used to avoid this problem. Finally, we have some specifications and testing, and just for you to have an idea, for the cans, so we measure dimensions, the weight, the capacity, the opening force. There is equipment to measure the opening of the easy open ends, and the double seam evaluation is maybe the most critical parameter. Then we have the coating specifications, and we have here a number of examples. Thickness and grammar again. How well is this enamel is adhered, so we don't want the lacquer to be removed. This is measured in the laboratory. How porous is the lacquer is also a measure of quality control. And then the chemical and thermal resistance together with food compatibility and migration tests. So migration tests targeting the components of the lacquer, like the phenols that are coming from the epoxy phenolic type of coatings, for example. BPA, bisphenol A, have you heard about this bisphenol A? I'm sure, batch, and so on. So there is a number of migrants typical that must be evaluated under the food contact material recommendations and legislation. Okay. So this is the end of metal cans section. It was rather quickly, so because it's a little bit new, I think, but I hope that you had a different idea now on the different aspects that must be taken care in metal cans.